question 7. So part A, pretty straightforward. This is just SOHCAHTOA, so we know the ship's moved 3 to the left, 4 up. That allows us to work out the acute angle being 53.13, because tan x is 4/3. We want the bearing, remember this is measured from north, so 90 less 53.13, which is 0.37 to the nearest degree. Now for part B, remember how we do the equations for the ships. We basically have the initial position and then a multiple of the velocity. Initial position and multiple of the velocity, each time the velocity being times by t. Now for part 3, just remember to go from P to Q, when we've got position vectors P and Q, we're basically doing a minus P plus a Q, or in other words a Q minus a P. So it's Q minus P, Q minus P. So no i's, take away an I is minus I, minus 2 minus 1 is minus 3, 3 minus 2 is 1, 4 minus minus 3 is 7. Now for part C, we're just part 1, Q is due north of P. Q is due north of P, so basically if you just imagine this the other way around, Q above P, so Q to P, there's going to be no sideways movement, it's just upward movement, so the I coordinate is going to be 0. So basically when Q is due north of P, so Q is north of P, there's going to be no difference, no movement in the I coordinate, because Q and P are both on the same I coordinate. So just considering the PQ vector, we need the I factor to be 0, the I coefficient to be 0, so minus 1 plus t has got to equal 0, so t is 1, so this is 1 hour after 2 p.m, so that's 3 p.m. Now for part 2, we're trying to consider when Q is due north of P. Q is is northwest of P, So this is the scenario. So we've got a minus I plus a j. So basically the coefficient of I equals minus j. So so again, looking at PQ, we need the I coefficient. So that again is the minus 1 plus t, on this occasion to equal minus j coefficient, so minus 3 plus 7t. So we need to solve this, so t is a half an hour after 2 p.m, that's 2:30 p.m.